Hello and welcome to this video. In this video, I'm going to walk you through the process of creating the Simulink subsystem that allows you to sense and measure the red cart's position, velocity, and the impulse forces acting on the red cart. So the very first thing that you need to make sure you've done is to open up the task 1 script and run it. So let me click on the Live Editor tab sheet and click the green Run button. You might recall from the introductory video, by running this task 1 script, it simply loads into your MATLAB workspace MATLAB variables, which we're going to use within the Simulink model. That's step 1. Step 2 is you'll see that we have a file, which is a Simulink model file called My Partially Completed Model Impulse Momentum. So I just want you to double click on that file and open it. So here it is. This is the model that you're going to complete. It's partially completed for you already in the sense that the subsystem that represents the model, it's already done for you, so you don't need to do any extra work there. If I sort of go back to the root level of the model, the subsystem that does need some finishing off is the one called Sensors and Data Logger. So let me just use the model browser just to click on this subsystem called Sensors and Data Logger. Yeah. Okay. So clearly these two big red question marks are a bit of a highlight that this is where we need to sort of finish it off. So the first thing I'm going to do is I'm just going to sort of delete these question marks. They were just placeholders. And what I'm also going to do is just to sort of get myself ready to have the Simulink library browser open, I'm just going to sort of try and position the model editor to have about 2/3 of the screen. That'll do. All right, so this is the subsystem that we need to finish off. And what we need to do is click on the library browser. So go to your simulation tab sheet, look for this icon called library browser. And this will open up the library browser, which is the repository for where you'll find all of the Simulink blocks that you can use to build up your models. So just scroll to the very top of the library browser. There's a sub-library called Simulink. Just click the icon on the left to sort of expand it. And you'll see that one of the sub-libraries in the Simulink library is called Discrete. So just click on him. And the very first block that we need to add to this subsystem, it's right at the very bottom. So just scroll down until you find one called Zero Order Hold. Then left mouse click on the block and then drag it into your modeling canvas and then just release the mouse button. All right, that's the first block that we need. The next blocks are going to be in the Simscape library. So let's just scroll down in the model browser until we get to the Simscape library. And the particular sub-library will be utilities. Yeah. And in the utilities sub-library, we want a Simscape bus. So just drag one of those. And while we're in this utilities library, we also want 2 of these PS Simulink converter blocks, 2 of these guys. So just drag in 2 of those. There's only one more block that we actually need, and that's in the Simscape multi-body frames and transforms library. So Simscape multi-body frames and transforms, and the block that we want is called the transform sensor block. So just find him, drag him into your model. And that's it. They're all the blocks that we need in order to sort of complete this subsystem. So let me just minimize the library browser, and now I can sort of expand out my editing canvas. Okay, so let's do this. So what we need to do is summarized by the 4 bullet points. We need to measure the position and velocity of the front of the cart according to an observer at the O3 inertial frame. We need to sample the impulse force acting on the cart, and we need to configure the scope block to log data. We need to configure the model so that we actually save the log data back to the MATLAB workspace. All right, So let me sort of walk you through those steps. Let's do step 2 first. Sample the impulse force acting on the cart. That's where we're going to sort of use that zero order hole block. Yeah. So just grab the zero order hole block that you've already dragged into your model, and just kind of connect it as shown. Yeah. So if that didn't sort of work for you as easily as it did for me just now, then look, we've deleted all of the lines. I'm just positioning the zero order hold in place. And then I'm going to this block. I'm just connecting a signal line, and then going to the other side of the zero order hold block and connecting a signal line. So what we want to make sure is you want to make sure that that this signal here is labeled F_n. So let me sort of just delete, well, let me just sort of overwrite this with some sort of default value. So the way that you make sure that this wire is labeled correctly is just click on the wire. Yeah. In fact, double click on the wire of interest, and then you'll get that little vertical editing marker. And now you can just sort of type in F_N. It's really important that you obey case sensitivity, because we'll be utilizing the names of these signals in an analysis script that will run in a few minutes' time. So you've wired it up, you've made sure that you've labeled this signal, really important. Now we need to configure this zero order hole block. And if you have a look at the two orange zero order hole blocks that are already in the diagram, it kind of gives it away. Yeah. So for these orange zero order hole blocks, we've configured them by specifying a particular sampling time that's going to be used. Yeah. There's a MATLAB workspace variable called mesh.ts. Yeah. So let's go to our zero order hole block, double click on him, and we want to specify exactly the same thing, MEAS dot. And you'll see that there's some nice heuristics in this sort of editing environment. As soon as you type in mesh dot, it says, hey, do you want to complete this with TS? You can say yes, please. You can click apply, and then OK. Awesome. So we've just completed part B, sample the impulse force acting on the cart. All right, let's go to part A. How do we measure the position and velocity of the front of the cart according to an inertial reference frame at 03? This is where this sort of Simulink bus comes in. The first thing that I'm going to do is I'm just going to rotate this block. All right, so let me click on the SimScape bus, go to Format, and you'll see up in the sort of Format tab sheet, there's a series of icons that if you just hover your mouse over, they give you little tips. Rotate 90 degrees clockwise. Yep, I need to do that one more time. Perfect. Now I can sort of connect this frames block to this SimScape bus. All right, so just sort of put your cursor near the port of the frames block, drag out a connection point, and then sort of connect it to this SimScape bus. We now need to configure the SimScape bus, so let's just double click on him. And here we're going to choose two frames that are meaningful for what we need to do. So to specify the frames that we're going to play with, just click this green plus button. And you'll see that you get a little sort of drop-down box in connection 1. So just click connection 1, and you'll see that it reveals a drop-down box. I want you to choose cart front. So this is one of those frames that are in our model. It's the frame that's attached to the very front of the cart. That certainly is an inertial frame. Let's click on the green plus button again, and we get another one of these sort of connection sort of rows. Click on the drop down and choose the frame called G03. That is our reference frame. Yeah. So if you've done that, your block should look something like this. Okay, you're done. You can dismiss the dialog box. Okay, the next step is let's play with this transform sensor. Yeah, so let's double click. Oh, let's wire stuff up first. Excuse me. So let's connect the port on the Simulink bus called G03. Let's connect that to the B side port of our transform sensor. Yeah. And similarly, let's take the port called cart front and let's connect it to the F side port on the transform sensor, just like that. All right, very good. Now double click on the transform sensor block and let's configure it. So the very first configuration setting that we need to do is this thing called measurement frame. It's a little drop down box, so click it, and the choice that we want to make is base, right? So what this measurement frame base selection does is it says that whatever we measure will be from the perspective of a base frame observer. The base frame observer for this block is connected to the G03 inertial frame. So we are measuring stuff according to an observer that is attached to the G03 inertial frame. Not only will the observations be made by this observer, but the components of the things that he measures will be expressed in components of the base frame. Okay, so this is setting number 1. Now let's choose the things that we want to measure. So let's go down to translation. I'd like to tick this X checkbox. Note the addition of the X port on the block. This gives us the position of the front of the cart. Next, let's go to velocity and choose X, and this will give us the velocity of the front of the cart. So what this transform sensor block does is it measures the spatial relationship between a base frame, which in this case is an inertial frame, and another frame. In this case, it is the cart front frame. Yeah, this is how we measure the position and velocity of the front of the cart. Okay, so now we can we can't directly connect these things into our orange zero order holds. This is where we need those interface elements, the PS to Simulink converter. So let's just drag those 2 blocks into position. Let's wire them up. And now we need to configure each of these converter blocks. So let's sort of start with this one. So I want to specify that the signal unit that is coming out of this block is in meters. You can just do that by typing in the letter M. Click apply. Let's go to the next one. This is the one where we're measuring velocity. Let's double click on it. And if you click on the drop down box, you'll see meters per second. You can choose that. Click apply. All right, so we're almost done, folks. So they're all the block settings and sort of connecting signals into the blocks. Now we need to finish it off with just 2 more things. We need to configure the pink scope block. Yeah. So let's double click on the pink scope block. Yeah. And when you do that, you'll get the sort of oscilloscope axis view of the scope. What we need to do is to click on this little configuration properties icon. It looks like a little gear icon. So just click on him. We get this configuration properties GUI that pops up. Click on logging on the logging tab sheet and look for the checkbox called log data to workspace. Make sure you tick that checkbox. And this is where we need to type in the name of a field variable that's going to store all of the signals that are coming into this scope. So I want you to type in exactly this, my _scope _data. Remember, be very careful of your case. Everything needs to be at the same case that I've shown. My _scope _data. And the data format that what we're going to choose is data set. Yeah. So logging, make sure that's ticked, and you need to configure these things. Once you've done that, you can click apply, and OK. And the last thing that you need to do to this model before it's ready to be used is go to the simulation tab sheet. Yeah. Look for an icon called Model Settings. Brings up the Model Settings sort of GUI, and then click on the category called Data Import Export. What I need you to do is make sure all of these checkboxes are not ticked. And then I want you to go to this checkbox, tick it, and specify this, my underscore sim underscore results. So this is what you need to do. Yeah. Again, pay particular attention to the case. It's important that you type in exactly what I've shown, because in the analysis script that gets used in task 3, we're expecting a variable to with this name to be in your base workspace. So click Apply and OK. So now in theory, you are good to go. So let's see if your model simulates. So just walk up to the simulation tab sheet, click on the green run icon, and bada bing, bada boom. Looks like your model is really good to go. Let's double click on the scope block, make sure that we're actually seeing time traces. Thumbs up, that looks really good. And the last thing that you just need to check to confirm that you've done everything correctly is have a look in your base MATLAB workspace, and you should see a new MATLAB variable called mySimResults. And this is the MATLAB variable that stores the time series data from the pink scope, the one that shows position, velocity, and impulse force. So that's it. That's all you need to do to finish off this model of this impulse momentum apparatus. Hope that helps.